Good day friends, welcome to Smart Book Guide. In today's video, we are going to be discussing about an example problem on Coulomb's law. The first part of the problem here says, determine the magnitude of what the electrostatic force Fe, right, between two electrons separated by a distance of 10 to the power of negative 10. So let's solve for the first part. We are given an electron, right, with another electron point charge, right? The distance between them is said to be r. So the givens here is that we need to know the value of q1 and q2. And as you can see, we are being given the value of what? An electron, which is this. So therefore, q1 equals q2 equals the electron. It's equal to 1.6 times 10 to the power of negative 19. Likewise, the distance, which is r, equals 10 to the power of negative 10 meter. The unknown here is the word, the electrostatic force. So all what we need to do here is to what? To solve for it. So Fe, we know it to be equal to K, Q1, Q2 over what? R squared. But K equals what? K is a constant and it equals 9.0 times 10 to the power of what? 9 Newton meter squared per coulomb squared, right? So we keep substituting. Fe equals 9 times 10 to the power of 9 times Q1, which is also equal to Q2 equal to the electron, 1.6 times 10 to the power of negative 19 times 1.6 times 10 to the power of negative 19. So then all divided by r squared, right, which is 10 to the power of negative 10 all squared. The next thing we need to do is that 9 times 1.6 times 1.6 times 10 to the power of 9 minus 19 divided by 10 to the power of negative 20, because minus 10 times 2 is going to give us minus 20. That equals 23.04 times 10 to the power of negative 29 divided by 10 to the negative 20. This also equals 23.04 times 10 to the power of negative 29 plus 20. Because if we take this minus 20 up here, we end up having it to become what? Positive. So Fe equals 2.304 times 10 to the power of negative 8 Newton. This is the first part of the problem which we have solved. So we have found what Fe is, and it is equal to what? 2.304 times 10 to the power of what? Negative 8. The second part of the problem is what? The gravitational force, which is Fg, between the what? Two electrons. So what we need to do here is, let's go solve for the second part of the problem. For the second part of the problem, our aim is to look for Fg, which is the gravitational force, and it is equal to what? G m1 m2 divided by r squared, which is quite similar to that of the what? Electrostatic force. So G, which is a constant, is said to be equal to 6.67 times 10 to the power of negative 11, right? Then m1, which is the mass, and we can see that the mass given to us as what? 9.11 times 10 to the power of negative 31. So all we need to do here is, to substitute m1 equal to m2, and it is equal to 9.11 times 10 to the power of negative 31 kg, right? Remember, r equal to 10 to the power of negative 10. So we need to just what? Substitute. Then Fg equals 6.67 times 10 to the power of negative 11 times 9.11 times 10 to the power of negative 31 times 9.11 times 10 to the power of negative 31, right? All divided by 10 to the power of negative 10 squared. This in turn give us 6.67 times 9.11 times 9.11 times 10 to the power of 11, negative 11 minus 31 minus 31, all divided by 10 to the power of negative 20, which also equals to what? A value of 553.557 times 10 to the power of negative 73, which is the upper part, all divided by 10 to the power of negative 20. Right? So if we simplify this, we end up having 553.557 times 10 to the power of negative 53 equals to 5.53 times 10 to the power of negative 51 Newton. So in that case, we can say that Fg equal to 5.53 times 10 to the power of negative 51 Newton, while Fe equals a value of 2.304 times 10 to the power of negative 8 Newton. So as you can see from this, the value of the electrostatic force, which is this, is greater than that of what? The gravitational force, because it has a power of negative 8, while this one has a power of what? Negative 51. If there is any question, feel free to ask. Goodbye.